Hello, everyone. Now this topic is about the super VLAN, and we already explained some principle, and you know how to work about this technology. And about this part, we will use a lab to show you some key configuration if you want to deploy the super VLAN in your network. First, let's see the background. Now, if in the large hotel, and our customer will use some switch to deploy some network service. And we will divide the switch to become core switch and access switch. So in the switch, we hope that the network security can be kept. That means if we have some layer 2 broadcast domain, and this domain should be isolated. And we have some requirement. One VLAN needs to be configured for a maximum of 2 rooms. As we know in the hotel, maybe we have lots of room, especially in the large hotel, maybe more than 100 or especially 200 or maybe more. If one VLAN only can be provided for maximum 2 VLANs, that means maybe VLAN is not enough. And about the IP segment, according to the network plan, the hotel network has only one IP address segment, and the segment is 172.16.1.0/24. So now if you are the network administrator, we hope you can use a super VLAN technology to meet the hotel's network requirement. And about this lab, our purpose is first, we have to learn about the application scenario of super VLAN technology. Which scenario we can use this one? And the second one, we hope we can understand the principle of this technology better. Also, includes the super VLAN and the sub VLAN and what's the difference of the common VLAN. Then you can know some super VLAN configuration. And here is the topology. And on the left, I already deploy and give some network plan, includes the IP segment and also the VLAN. And about the requirement, switch 1 is a core switch. Now connect with the switch 3 and switch 4. 3 and 4 is our access switch, but they located in different layer. And another part is the third part switch is a switch 2. You can think the switch 2 in the lab is help us to test the connection between different IP segments. And as the topology shows, PC 1, 2, 3, 4 belong to 3 different broadcast domains. The domain IA is VLAN 10, VLAN 20, and VLAN 30. And we hope the L2 isolation is implemented for the domains, but they still can communicate with each other by the layer 3 communication. And the IP address segment of the domain, I already write down on the topology. Every segment we will have 5 addresses. And here is the address detail. And the switch 2 and the switch 1 can communicate with each other, but by the layer 3 interface. And finally, we hope PC5 also can do the communication with PC 1, 2, 3, and 4. So this is our requirement. If you want to meet the requirement in some configuration plans, first about the switch 1. Switch 1, we will deploy the gateway for all the terminal of PC 1, 2, 3, and 4. And also we will configure the super VLAN technology, includes the super VLAN 100, and the sub VLAN is VLAN 10, 20, and 30. And the VLAN gateway IP address is 172.16.1.254. And about the sub-VLAN, we also provide the IP address and like the topology IP address requirement. I already write down here. And you have to add the sub-VLAN on the access switch. Includes the configuration connect with PC interface and the configuration connect with our core switch, switch 1. And another one is between the switch 1 and 3, switch 1 and 4, because this link may be forwarded multiple different VLAN. So this interface must be set to become trunk. Okay. And because maybe all the terminals, we hope they can be isolated by the layer 2, but they still can communicate with each other by layer 3. But as we know, their IP segment belong to the same segment, right? About this IP address, if we use a mask 24, they located in the same IP segment. So how to communicate with each other by the same IP segment? We have to enable proxy ARP for the super VLAN. So this is the function of the proxy ARP. And between switch 1 and switch 2, we already said they must use a layer 3 interface, and then they can communicate with each other. And the segment is 12.0.0/30. So this is the IP address planning of switch 1 and switch 2. And because switch 1 and switch 2, they connect with a lot of terminals. So if all the terminals want to communicate with each other, we have to keep the routing information successfully. So on the switch 1 and the switch 2, you have to add the static routing. Of course, in the real network, maybe you choose a dynamic routing protocol, it also can work. And finally, you also have to give the correct IP address for terminals and also for gateways. Use the correct IP segment. So this is a configuration plan. And later we can explain one by one how to meet the requirement. First step, you have to create some configuration about the super VLAN. Includes the super VLAN ID and the sub VLAN. And also you have to add the relationship between super VLAN and the sub VLAN. And also switch 1 is a gateway of PC1 to PC4. So you have to give the correct IP address configuration. This is a basic one. Now let's do the configuration one by one. About the Ruijie switch 1, you have to enter the global and create a VLAN range. VLAN range, that means you can use one command and create multiple VLAN. You also can create VLAN 100, VLAN 10, VLAN 20, VLAN 30, the same result, 20 and 30, okay, and exist. And about the VLAN 100, it is super VLAN, right? And who will be the sub VLAN? The sub VLAN is 10, 20, and 30. Otherwise, if switch 1 receives a VLAN message belonging to VLAN 10, I will direct discard because our SVI interface, SVI is 100, right? If you add the relationship of super VLAN and sub VLAN, then when I receive the message from VLAN 10, I also will help to forward it by the layer 3 routing. So this is a relationship why you have to tell the VLAN 100 who is your sub VLAN and exist. And also switch 1 is a gateway of all the terminal. So you have to create the SVI interface VLAN 100. And the IP address is 172.16 16.1.254, the max is 24. So it's okay. And then you can check some result. For example, show VLAN. And about the show VLAN, you will find the VLAN 1, it is located by default, right? But we also create VLAN 10, VLAN 20, VLAN 30, and VLAN 100. And the state of this VLAN, the 100 is super VLAN, but 10, 20, and 30 is a sub VLAN. So this is description. And you also can check the IP address you create for the SVI interface. Show IP interface brief, and you will find the IP address is 172.16.1.254. But now you will find the state is done because no one physical interface can help you to forward the VLAN 100 information. By default, all the physical interface of the switch will only can forward the VLAN 1. So that's why the state is done. And then another is you have to setting the IP address segment of the 3 sub VLANs. So the command is VLAN 10, and then what's your sub VLAN? Sub VLAN address range is from 172.16.1.1, and the biggest IP address 172.16.1.5. Okay, and another for VLAN 20, the range is from 172.16.1.11. Biggest IP address is 172.16.1.15, right? And another one for VLAN 30, the range is 172.16.1.21. Biggest is 172.16.1.25. It is successful. And then you can show the super VLAN. Show the super VLAN. You will find now we will have the VLAN ID 100 is our super VLAN, right? And the proxy, now we don't enable the proxy function. And what's your sub VLAN ID 10, 20, and 30? And what's your IP arrangement? So this is a basic one for your super VLAN. And another one is for switch 3 and switch 4, because 3 and 4 connect with our terminals. So you have to create correct access interface. So on the switch 3, enter config, and you can create the VLAN 3 connect with VLAN 10 and 20. VLAN 10, right? And also create VLAN 20. Then you can enter the interface gigabit 01 and change the mode to become access. Of course, by default, the mode is access. And the default VLAN is VLAN 10. And another in the interface gigabit 02, the access switch VLAN is 20. Okay. This is the configuration of switch 3. And about the switch 4, also connect with 2 terminals. Configuration, and you also have to create VLAN 10. You can directly add the interface here. Gigabit 01. This is the interface connect with the PC2. And you can create VLAN 30. And add the interface. This is the same result with you do the configuration, enter the physical interface, and change the access default VLAN to become 30. The same result. different configuration type. So now if you on the switch 3 show VLAN, you will find the VLAN 10 and the VLAN 30 in the switch 4, right? And another one on the switch 3 also can show VLAN. You can see the VLAN 10 and 20, right? And between switch 1 and 3, 1 and 4, they must belong to the trunk interface. So you have to add the configuration here. On the switch 1, enter the range gigabit 0, 1 to 2. Okay, switch the mode to become trunk. In the switch the trunk, allow VLAN only 10, 20, 30. Okay. If we change the mode to become trunk, there is a warning will directly show you now your SVI interface 100, the state is up. Because by default, the trunk interface will allow all VLAN pass-through. So this is the warning. And suggest your trunk interface only allow your service VLAN pass-through. So this is a configuration of switch 1. And about the switch 3, you have to enter the interface, connect with switch 1, gigabit 00, and switch some mode to become trunk, and switch the trunk, allow VLAN only 10 and 20. Okay, so this is a basic configuration. Of course, if you allow VLAN everything, it also can work, but not security enough. 00 and switch the mode to become trunk. Okay, so this is a basic one. And another one, you have to enable the proxy ARP. Then the VLAN, between different VLANs, they can communicate with each other. In the configuration here, you have to add into the VLAN switch 1. On the switch 1, enter the VLAN 100, enable the proxy ARP. VLAN 10 and also proxy ARP. You also can enter range of VLAN at the same configuration proxy ARP. It also can work. VLAN 20, proxy ARP, VLAN 30, and also enable this function. Okay. And another one is between switch 1 and switch 2, you have to add the correct physical interface, and also you have to add the static routing. So on the switch 1, enter the gigabit 00. By default, the interface of switch is a layer 2 interface, so you have to become layer 3 first. And then you can give IP address 12.0.0.1, 30. And exist. Because about the switch 1, now you give the correct IP address of SVI 100 and also the physical interface gigabit 00. Switch 1 only have 2 direct routing, right? But switch 1 doesn't have the segment of PC5. So you have to add the routing information. Here we will use the static routing, IP route 192.160.1.0, 255.255.255.0, and the gigabit 00, and the next hop is 12.0.0.2. Okay, so this is a basic configuration of switch 1. And about the switch 2, here you have to enter the physical interface, connect with switch 1, change the mode to become layer 3 interface. In the IP address 12.0.0.2, 30. And another one is a gateway of PC5. We use the VLAN 1. You also can use the other VLAN, but here we use the default VLAN. And the IP address is 192.168.1.1, the 1.254.24. Okay, and also now the switch 2 we only have 2 direct routes. So IP route, we only have 2 direct routes, right? We don't have the routing information of PC1 to PC4, so you have to add the static route. IP route 172.16.1.0, 255, 255, 255, 0. Physical interface 8 gigabit 00. Next hop is 12.0.0.1. Okay, so now you can show IP routing. You will find we already added the static routing successful. And about all the PCs, you have to give the correct IP address. For example, about the PC1, IP 172.16.1.1, mask is 24. Gateway is SVI interface of switch 1. Okay, so this is a basic of PC1. And another of PC2, IP 172.16.1.5, 254, 255, 255.0, gateway. Okay, and another one for the PC3, IP 172.160.1.11, 255, 255, 255, 0. Okay. And the PC4, IP 192.16.1.21. The 1.254. Not same subnet. Or I give the wrong IP address. Surely 172. Okay. And about the PC5, this located another IP segment, 192.168.1.1, 255, 255, 255, 0. Gateway. Okay. So now all the IP address successful. We can test the result. On the PC1, PC2, and PC3. For first, PC1, can we ping PC2 successful? 1.5. You will find we can ping each other, right? PC1 and PC2, they located in the same VLAN and same IP segment. So you will find the TTL value will be 64. That means they forwarded the message with each other by layer 2 network. But if you want to ping the other VLAN, maybe we have to use our gateway to help us for the message. So if you want to ping PC3, 172.16 16.1.11. You will find the TTL value will be cut 1, right? Although we located in the same IP segment, but this message, we already use a gateway to help us by the ARP proxy. And also, if you want to ping PC4, the IP address is 21. The TTL value will be 63. So this is a result. And this is a network connection between the same IP segment. If we want to ping different IP segment, for example, in PC5, to ping PC1, 172.16.1.1, we can ping successfully, right? Because we use routing information in switch 1 and switch 2. And also, if you want to ping PC2, 1.5, we can successful. And if we want to ping PC3, the IP address is 11. They also can work. And the last one is PC4. The IP address is 21. It also can work. So the network between different segments, we also can communicate with each other. And in this configuration, this lab, the key part is we use super VLAN and sub VLAN. So PC 1, 2, 3, and 4, although they in the same IP segment, but they belong to different broadcast domain. And if we want to communicate in different VLAN, you must to enable the ARP proxy in your gateway, switch 1. If you want to communicate with the other segment like the PC5, you have to add the correct routing information. So this is a key point. And another is the most important for the proxy ARP, you have to enable. So about the proxy, you can check on the switch 1. Show super VLAN. You will find now the ARP proxy is enabled, right? If you want to close the ARP, then you can test the result again. VLAN range 10, 20, 30, and 100, and no proxy. You close it, right? And in the PC1, you can test again. If you want to ping the PC2, 172.16.1.5, I think we can ping successful because we located in the same VLAN. We don't need to use a proxy ARP, right? It can successful. But if you want to work with different VLAN, PC3 and PC4, they cannot. 11. They cannot, right? Because switch 1 also will receive this ARP from PC1. But because we don't enable the proxy ARP, so I will directly discard it. The same if you want to ping PC4, they cannot ping, okay? But if you want to ping the PC5, 16.1.1, they still can ping successful because we use the normal routing information to communicate with the other IP segment. So you have to know this one. And another is if you only enable the proxy on the sub VLAN, pay attention like this one. Now on the switch 1, super VLAN and sub VLAN, all of them disable the proxy ARP, right? But now if you only enable the sub VLAN, 10, 20, and 30, and enable the proxy ARP. So you can test the result again. PC1, if you want to ping with PC2, they can communicate with each other. If you want to ping PC3, 11, cannot. Also PC4, 21, cannot. But if you want to ping PC5, different IP segment, it can work, right? So if you only enable your sub VLAN, it also can work with each other. You can do the communication within the same sub VLAN. And also you can do the communication with the other segment, with the other IP segment. Okay, so this is a test. If you only enable the sub VLAN ARP proxy, that means different VLANs still cannot communicate with each other. And another test is if you disable the proxy ARP for sub VLAN, but your super VLAN can support the proxy ARP, what's the result? So now for your sub VLAN, you have to enable your proxy ARP. But in your VLAN 100, this is your super VLAN. You enable the proxy ARP. What's the result? PC1 to ping PC2, they can communicate with each other. But if you want to ping PC3, 11, they cannot. PC4, they cannot. But if you want to ping the other IP segment, it also can work, right? So in this scenario, we only enable the proxy ARP in a super VLAN, but the sub VLAN cannot support the same result with the second scenario. So the solution is, if you want to communicate between different sub VLAN and also with the super VLAN and also the other IP segment host terminals, you must enable the proxy both super VLAN and sub VLAN. So this is a relationship. If one VLAN is limited without the proxy ARP, the terminal located in different VLAN, they cannot communicate with each other, although maybe their IP address belongs to the same segment. So this is the result. That's all about this lab. Thank you.